Hello and welcome to my channel. My name is Alfonso Peluso and I'm a Studio Associate Professor in the College of Architecture at IIT, where Mies van der Rohe came all the way from Germany to start the modernist architecture movement. Today we're going to be looking at 3D printing best practices and primarily at post-processing 3D prints, also called slicing. So we're going to look at some important topics in getting the best 3D prints possible in the shortest amount of time using the least amount of material. That's what's important here. And before we jump into it, if you've been here before, thank you very much for tuning back in. If this is your first time, please subscribe to my channel. And if it's your first time or if you've been here before and you haven't clicked the little bell in the upper right, please click that to receive notifications on when my videos have been launched. So today we're looking at 3D printing, but my page has a lot of videos on a lot of different topics, so hopefully there's something for you that you find interesting. Secondly, connect with me on Instagram, see what I'm up to, see what videos have come out, are coming out, see what I'm working on with my students at IIT. That's at my first name underscore my last name. Okay, today we're looking at 3D printing best practices and specifically on post-processing, or what is called slicing. I'm looking at Cura. Cura is the post-processing software for the Ultimakers. Now, I will tell you, most of these post-processing software applications are very similar, and that's why I want to cover the foundations. These foundations that we cover today will allow you to look at any 3D printing slicing software and get the best output from those applications. So this is Ultimaker Cura. Okay, so this is what the interface looks like. And I'm just going to walk us through this. So again, if you're in another software application, slicing application, it's very similar. Okay, so I'm going to go ahead and click on the folder, and I'm going to bring in a simple cube. Now this cube is 50 millimeters by 50 millimeters by 50 millimeters. So that's one topic to talk about. These 3D printing slicer applications, they are set up in millimeters. Okay, so that's something that you should understand. So we're looking at the units of millimeters, and this is roughly 2 inches by 2 inches, so it's a pretty small cube. So typically you'll open the file, and I like to use STL files, stereolithography files, to bring into my 3D printing software. So we'll open it, and then depending on what type of 3D printer you're using, you're going to want to add that 3D printer. So there's always a bunch of 3D printers to choose from. As you see here, there's a bunch of Ultimakers. Okay, so I'm keeping it as the Ultimaker 3. Now the Ultimaker 3D printers, they are dual extrusions, meaning they have 2 printer nozzles, and you're going to want to set the material for each of those. So I'm going to go ahead and do that. So these are color coded at the moment by the type of material. So extruder head 1 is enabled and the material is PLA. And you can see there's other types of materials that you can select from. And then this just gives you an example or shows you how that these are color coded, and we'll see that a little further into the video. So for this particular printer, I'm using PLA, stands for polylactic acid. That's the type of 3D printer filament I'm using. And then the print core is AA 0.4. So that's extruder, extruder nozzle number 1. Extruder nozzle number 2 is going to be using PVA. This is polyvinyl acid printer material. So that's going to use print core BB 0.4. Okay, so we have our two nozzles set up. The next thing we want to look at is the print settings. Okay, so the main ones that we want to look at are quality, infill, and speed. Those are the important ones. And again, in whichever post-processing software you're using, you're going to be able to find those settings: quality, infill, and speed. Okay, I want to step back for a second and just talk about where these files for 3D printing can come from and what you should be looking for. So here I have a couple objects in Rhino. And what I have here, if I type in the command what, this is just a poly surface, a closed poly surface. Okay, it says valid extrusion. This closed poly surface is something that I converted to a mesh. Okay, meshes are what I use to make my STL files. So if I select that and I type in what, you see that that's a valid mesh. And in Rhino, there is a command called check. And when I check it, it says this is a good mesh, and then it doesn't have any of these unwanted components to the mesh. And one of the main things that I look at when I'm creating meshes for 3D printing is I look that the meshes do not have any naked edge. If it has a naked edge, that would mean that it is not watertight and something could leak out of it. So when I'm 3D printing, I need to make sure that all my meshes are watertight. Okay, so the cube is something we'll look at that doesn't require any support. And then I have the same thing here. This is another closed poly surface. When I checked that box, it said it was just a valid extrusion. But here we can see a closed solid poly surface. So that's multiple surfaces joined together, watertight. And I converted that to a mesh, and if I use the check command, we'll see that this is a good mesh, and it does not have any naked edges. So these two meshes, the cube and the model here, are good to go. The difference between these is the cube is not going to require any support material. This object is going to require support because something needs to hold up. We'll call this, if this is the roof coming across, something needs to hold that up, and the same goes for this mesh. Something needs to hold that up. So we're going to need to print those with support. So two types, one without support, one with support. Okay, so let's go back into Cura here. Okay, so we have this cube, and let's look at how long this is going to take to print. So that's the big thing today. We want to be able to make sure that our prints print quickly, basically the least amount of time and the least amount of material, and then we'll talk about the trade-offs with quality. Okay, so right now right now this is set to the default of fine, and I'm just going to go ahead and slice that so we get an idea of how much time that's going to take. Okay, so that says it's going to take 6 hours 57 minutes. So that's a long time for a 2-inch cube. So we want to definitely reduce the amount of time it's taking to print that. Now at the top here, I have prepare, preview, and monitor. If I click on preview, it's showing me what that slice model is going to look like. And we'll come back and look at this after we make our final settings. But I just want to compare some of the different default settings. So that's fine, and you'll see that in most 3D printer post-processing software. So that's fine. If we drop it down to normal and we go ahead and we slice that, we're looking at 3 hours 57 minutes. Okay, so half the time just by changing one setting or one preset. And then if we go and look at fast, and we go ahead and slice that, we're down to 2 hours. So from almost 7 hours to 2.5 hours. And what we need to do is we need to look at the differences between those. Why is one faster than the other? Why does one use more or less material? So you see here, this one's using 47 grams. And just to get an idea, what did the fine use? Okay, the fine is using 48 grams. So get an idea of time and material that's being used. Okay, so let's run through the settings. Okay, so we're starting with quality. Now quality I also think of as layer height. So when we get down into that, it says layer height. And the smaller the layer height, the higher the quality. The thinner each layer is, the higher the quality. But of course, the longer it takes, because 3D printers start from the bottom and they build up. So the smaller the value, the longer it takes to build up. The higher the value, the shorter it takes to build up, but you lose some quality. And in many cases, that's okay. In working with my architecture students, we're trying to look at design options. We're trying to iterate. So we want our prints out very quickly. In the beginning, we're not so focused on the quality. That's something we can do at the end when we have the design chosen, the design that we want. Then we can go to higher quality. Okay, so let's go ahead and set the layer height. We're going to set that. So I'm looking at making some custom settings. Now I could start with fast. I could go ahead and start there. And then my layer height is already going to be 0.2 millimeters. Okay, so that's going to save me some time, as we saw previously. Shell, that's for more advanced users. If you're trying to get lightweight model parts and you want to adjust the shell thickness, you could do that. But for beginners, I would recommend leaving the shell alone. Now, next we have infill. Okay, let's get a look at what infill is before we actually change the setting. So what is infill? I'm going to go ahead and slice this. And I'm going to switch this to preview, and I'm going to drag this little slider down on the right. And now we can, what this is doing is it's showing each individual layer as the 3D print builds up. So this is all the way at the bottom, and this is up toward the top. So the infill is the triangular pattern that you see here. And different types of infill create different types of model qualities. Whether you want the model to be soft, you can choose a certain type of infill, or if you want it to be really strong in all directions, you can choose another type of infill. And here's all the different types. So the grid is one that is strong in all directions. Okay, there you see that. So you can do a Google search on infill patterns, and there's a lot of information out there. There's a couple cool ones, like if you want to print something and maybe stop it halfway through, there's some neat ones out there. Like this one is pretty neat. Just take a look at that. Okay, so that's infill. So let's keep going with this. So what I want to say about infill is you don't always need so much infill. So this 20%, which is the default infill, that is a heck of a lot of infill. Okay, if you're not using this part to be structural, or if it doesn't need to be durable, if it's just a design model, you can get away with lowering this number considerably. So I'm gonna put my infill down to 5%, and I'm gonna leave it at the default, which was triangles. Okay, now we're gonna move on to material. Okay, now material, it has temperature settings, and unless you're an advanced user, you're gonna want to leave these temperature settings alone. Sometimes better filament works with better temperatures, and that again, it comes from experience. It comes from doing a lot of 3D printing where you would be able to start to make adjustments to those settings. While I'm here, I do want to make sure that enable retraction is on. Okay, and it says retract the filament when the nozzle is moving over a non-printed area. So that gives me some clearance. So I want to make sure that that is checked on. Okay, moving down the list here. The next one is speed. Okay, now speed on this particular printer, it has settings for extruder number 1, extruder nozzle number 1, and that's what's printing the model material. Extruder number 2 prints the support material, and again, we'll get into that a little bit down the road here. But for right now, the speed for the extruder that is creating the model material, that default is 70 millimeters per second. So if it's moving faster, obviously the print is going to take less time to print because the nozzle head is moving faster. But there's only so much play you have there. For this one, if you're looking for higher quality and you don't care so much about time, you could use a setting like 50. If you're in a real hurry, you could go all the way up to 80. So I'm gonna use 75 for right now, just experimenting with speed, trying to save a little time. That's the speed for nozzle 1. That's the speed for the build material. If I go over to nozzle 2 or extruder 2, it also has a speed. And the speed for extruder 2 needs to be slower. It's using this PVA material, which is printing the support material, which is it's a water soluble material that will disintegrate in water. We're going to need that to be slower, between 30 and 50. Okay, so I'm going to go ahead with 45 here. Okay, so that's speed. The next thing that we have is travel. Now for travel, we have one setting, Z-hop when retracted. Okay, this is another one of those settings that keeps the nozzles from running into your object that you're 3D printing. And what this actually does is it reduces, or it actually lowers the bed. It lowers the printing bed. It lowers the bed height down so that the nozzle can pass by your 3D printed object. Okay, we have cooling, and we want to make sure that enable print cooling is turned on. And then we have support. Now this cube, as I mentioned before, does not need support. There are no overhangs, there are no roofs to hold up. So we're going to just keep that off for now. Next is build plate adhesion. I would check on enable prime blob. That just gets things going, gets the nozzles unclogged. The build adhesion type. The two that I've used are brim and raft, and we'll see these when we do the post-processing, when I hit the slice button basically. But brim is for most models. If you have let's say a sphere that doesn't have a lot of contact with the build plate, then you could choose raft, but we'll leave it at brim for now. And the build plate extruder, we're gonna set that to extruder 2. So that's something that's important, that we set that to extruder 2. That's using the support material. Okay, it's a lot easier to separate your model from extruder 2 from the PVA than it is the build material. Okay. All right, now the last one is dual extrusion and enabling a prime tower. Let's zoom out here. Let's see if I enable that. Yeah, so a little object shows up over there. So for very fine, small, and delicate objects, you're going to want to check this on, because what this helps with keeping the extruder nozzle clean and clear. Otherwise, sometimes with these small, fine models, these extruder heads or nozzles can tend to clog up. So that's going to help that from clogging. I'm going to go ahead and leave that off for now. Okay, so let's look at what happens when we slice this. Okay, so let's go ahead and bring this all the way up. Okay, so what you're going to notice now is we see the color coding. Okay, we see the purple color, so I know that's extruder 2. So you really want to pay attention to this preview of the slice. You want to make sure that the build brim or build raft is purple, because that's what extruder 2 is set to, and then the material color is a yellow color. And as I start to look down into this, I can see my infill material, and that's enough infill to print the top. Basically, that infill, what I need that for is to print the top of that cube. Okay, so now we're down to an hour and 41 minutes of print time. So we started out with 7 hours. So that's what makes these settings very important. Okay, so let's now bring in the object that had the support and take a look at turning on support and how we're going to do that. Okay, so I'm just going to go back to prepare, and I'm actually gonna open that file. Okay, this is the one that needs support. Okay, so we see that behind it. Just went ahead and deleted the other one there. Okay. Okay, now we'll go ahead and turn on our supports. So I'm going to go to the settings, and I'm going to go down to support, and I'm going to click on generate support. Now, supporting adds a lot of time. So before we add the support, I'm going to click on slice just to see. Okay, so this is an hour 43. But what could happen with this model is, if I don't have support on, as it starts to lay down those layers, you see these layers that start to show up that span across this opening. Those layers could start to sag. And I've printed 3D models like this one without support to save some time and save material, mainly saving time, and just if I want to look at something quickly. And I've gotten these to work, but with the sag. So if you're a beginner into 3D printing, you're going to want to turn on the supports, and that material is going to need to have support. So it's an hour 43 without. An hour 43 without supports. So let's go ahead and turn on the supports and look at the differences. Okay, so under support, we're going to click on generate support. And then we need to set that support to extruder 2. That's very important. Extruder 2 needs to be set for support. Support placement can be everywhere. And support overhang, it's recommended between 0 and 45 degrees. Okay, so let's see now what this does when we go ahead and slice it. Okay. So we've added a little bit of time. It was about an hour 43. Now it's 2 hours and 36 minutes. Okay, let's bring this all the way up. Okay, so now you're seeing this support material here. Okay, you're seeing that in the purple. Okay, and again, that's the water soluble material that's going to just disintegrate when the print is done. Okay, that covers the 3D printing best practices. Thank you for watching, and I'll see you next time.